Hello and welcome to my YouTube channel ChemWis. In this video we are going to learn an important name reaction, that is the Albright-Goldman oxidation. In this reaction, a primary or secondary alcohol reacts with an intermediate in situ generated by the reaction between acetic anhydride and DMSO at room temperature to produce aldehyde or ketone. Mechanism of Albright-Goldman oxidation. DMSO has nucleophilic oxygen and acetic anhydride has electrophilic carbon. Attack of DMSO oxygen on electrophilic carbon of acetic anhydride followed by elimination of acetate ion gives acetoxy dimethylsulfonium acetate, which is active species in this reaction. Alcohol then attacks on sulfur of active species, which is assisted by acetate ion to produce acetic acid and alkoxy dimethylsulfonium ion. Methyl protons are acidic due to presence of positive charge on sulfur. Acetate ion then abstracts one of the methyl protons to produce this sulfonium ylide, which removes dimethyl sulfide to produce aldehyde or ketone. Examples of Albright-Goldman oxidation: 1-propanol, benzyl alcohol, 2-propanol and 1-phenylethanol when undergo Albright-Goldman oxidation produce propionaldehyde, benzaldehyde, acetone and acetophenone respectively. This is an alkaloid having secondary alcohol group. When it is allowed to react with acetic anhydride and DMSO at RT, produces corresponding ketone. Another example. In this case also it has secondary alcohol. After Albright-Goldman oxidation, it produces ketone. Let's have an example of sugar derivative. Here also we can see that there is a secondary alcohol group. When it is oxidized under Albright-Goldman condition, produces corresponding ketone. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.